Hello guys, and welcome back to another one of the A-level physics videos. Again, we're still on the mechanics topic, and today we're going to be talking about weight and gravitational field strength. So it should be noted that this is kind of split in two almost, because this is the mechanics part of weight and gravitational field strength. So it's not going to cover actual gravitational fields, okay? So the equation for weight in general is just mass times g, where m is mass in kilograms and g is equal to the gravitational field strength or gravitational acceleration. Gravitational field strength. So, and the units for this are newtons per kilogram. So when you multiply the mass in kg by newtons per kg, you're going to get weight in newtons. So, why is this important? Well, in A-level it kind of comes back again, but this gravitational field strength thing here is pretty important because they can give you situations where you might not be on Earth. Now on Earth, you need to memorize gravitational acceleration as being 9.81 meters per second squared or newtons per kilogram. Okay. However, they could easily put you, for example, on the Moon or Mars or Venus or Jupiter, which all have different gravitational field strengths. And the important thing here is that they can ask you conceptually what that means for the weight and what that means for the mass. Now the mass is the amount of stuff an object is made of, okay? So this will never ever change no matter what planet or even if you're just in space. Whereas your weight is actually the force that you are exerting on the ground, okay? And it comes from how strongly the planet or the Moon or whatever you're on is pulling down on you. Okay, so for example, if they asked, an astronaut weighs 200 newtons on Earth, he goes to the Moon, what will happen to his mass, what will happen to his weight? Well, his weight would decrease, his mass would stay the same. Okay. Now a few more things about gravitational field strength is that when objects are falling, so objects in free fall, will fall or with the acceleration of g. Okay, so on Earth, everything that falls on Earth can be assumed to accelerate downwards with at a rate of 9.81 meters per second squared. And if it's on the Moon, it's about a third of that, so about 3.2. And on Mars, it's something that's 30% less. So this is something you need to keep in mind whenever you're doing kind of free fall or talking about terminal velocity. It's also important to note that this is only if we neglect air resistance, okay? Because of course air resistance kind of messes things up. Now this also means that in space, where g is practically zero, you don't have any weight at all. Next thing I want to talk about with weight is that you always need to include it whenever you're doing any kind of mechanics calculation. So it could be a situation where you have a box on the ground, or you could have a ball on an edge or something like that. The weight will always act completely vertically down. It has no horizontal component whatsoever. However, this doesn't mean that it doesn't cause any kind of acceleration left or right. If you notice here, the weight's going straight down, but since it's going straight down on a sloped surface, the ball or the object will still accelerate downwards. And this should also be noted. We're going to talk about this a little bit more in the Newton's third law video, but this weight is always going to create a reaction force that goes directly opposite or perpendicular to the surface it's resting on. So in this case, since we have a flat surface here, or approximately flat, R is perpendicular to that. And likewise here, since we have a slanted surface, it's going to be perpendicular in this direction. In terms of weight, the key thing that you need to remember is that this is the equation you need. Weight is equal to mg. You're going to use it quite a lot, but you need to make sure that you are actually on Earth if you're going to use 9.81. They could easily change this and make it quite simple. There aren't really any exam questions that we can do that just talk about weight. Normally they're parts of other questions, so I think we will leave it there for now.